Hello everyone, we are Emmet Communication Technology Co. Ltd. Today we are mainly going to introduce something to you.
Single and double star optical cables are common. What are the structural differences? Let's see their appearance. A double core cable has two twisted fibers, called a figure 8 cable. One fiber is single core, two is double core. The first noticeable difference is color.
This is a double core cable with two parallel fibers known as a figure 8 optical cable. One fiber is single, two are double. The colors differ. One is yellow, the outer color. When there are two fibers, we call it double, which is why it's referred to as double core. The first thing we notice from the appearance is that you can see the colors are different. This is yellow. This is its outer color. We can see that it is yellow. Optical cables have an optical fiber, simulated sand for strength, and a colored sheath. Tensile strength is crucial to distribution. Thinner cables are weaker. Sizes like 1.6, 2.0, and 3.0 limitum offer varying strength, with 3.0 limitum having 150 newtons short-term and 80 newtons long-term strength. Next, it uses simulated sand with a colored sheath. Tensile strength has specific requirements during wiring. Thinner optical cables are more. Sizes like 1.6, 2.0, and 3.0 vary in diameter. Larger diameters mean stronger tensile strength. For a 3.0 cable, short-term tensile strength is around 150 and 80 newtons. Now let's look at the outer sheath materials. For example, this optical cable comes in sizes like 1.6, 2.0, and 3.0. Similarly, our standard models have different diameters. The larger the diameter, the stronger the tensile strength. There's an indicator for optical cables called short-term and long-term tensile strength. For a 3.0 optical cable, its short-term tensile strength can generally meet around 150 newtons and 80 newtons.
It's equivalent to. Let's take a look at what are the differences in the materials of its exterior sheath.
The outer sheath actually comes in several types. The ones we commonly use are PVC, low-salt halogen-free materials, and TPU. Among these, as you may know, low-salt halogen-free materials are important because many people have suffered injuries or even fatalities due to smoke inhalation during fires. This effectively addresses that issue as it is still non-toxic, which is why it's called halogen-free.
All right, so while we were discussing its structure, we also heard a term, reinforcement. What differences are there in the reinforcements? Well, the reinforcement is actually crucial for the tensile strength. It plays a major role in meeting the tensile requirements.
But currently, the mainstream options for soft optical cables have two types of reinforcements. One is called spun yarn, and the other is called polyester sand. From an appearance standpoint, the colors of the two are quite similar, but in reality, the best option that can meet the highest tensile modulus is the dust-proof yarn.
All right, so that's it for today's introduction to the new optical cables.